The climate of Northern Ireland was also far warmer, with average summer days 60 million years ago averaging a high of 31 degrees Celsius or 87.8 degrees Fahrenheit. Its proximity to Greenland, which truly was green and completely ice-free at the time, was important, as underlying the eastern coastline of Greenland was the center of the Iceland mantle plume, also called the Iceland hotspot. When this mantle plume interacted with an area slowly spreading Greenland and the British Isles apart, it accelerated this process while also sending large volumes of molten rock upwards into the increasingly thinning crust. This caused groups of near-simultaneous large-volume effusive eruptions, some of which involved hundreds of thousands of cubic kilometers of molten rock. These eruptions occurred on fissures dozens to hundreds of kilometers in length, which initially occurred offshore of Baffin Island in Canada, western Greenland, eastern Greenland, and most importantly in a north-to-south trending band of activity running through western Scotland and eastern Northern Ireland. In some areas, flood basalts more than a kilometer thick of black basaltic lava was emplaced, hence the term flood basalts, as part of the first phase of what was referred to as the North Atlantic Igneous Province. 6 such eruptions formed distinct layers of rock now exposed in cliffs half a kilometer east and west of the Giant's Causeway. Eruptive activity then resumed once again, and per a new theory which I personally agree with, a large volume of molten rock intruded underneath the modern Giant's Causeway. Magma then rose from the side of this magma chamber, draining it, and causing the ground overlying it in a north-to-south trend to start subsiding, forming a valley of sorts. As several hundred-meter-high lava fountains erupted from fissures nearby, molten rock flowed downslope, eventually reaching this valley at it represented a low point. Basaltic lava then pooled to depths upwards of 90 meters, forming a long-term lava lake which would take a substantial amount of time to cool. Once the eruption ended, the lava began to cool in a largely top-down manner. As basalt columns formation this occurred, the lava contracted, and the best way to accommodate this motion via the least rock movement was to form a series of near 120-degree angle cracks that eventually formed polygon shapes, albeit primarily 6-sided hexagons. These hexagon-shaped cracks then propagated downwards, as once the process began, going further down required less energy. By the time the cooling had completed, a series of hexagon-shaped columns, more than 40,000 hexagonal basaltic columns had been constructed. Another basaltic eruption then covered this layer, and if you are wondering why you don't see it today, the reason is that it was subsequently eroded away by glaciers during the Pleistocene epoch along with erosion from wind, waves, and water. This allowed for groups of basaltic columns to become exposed on the surface. These columns are today one of the most visited geologic attractions in the region, which is not a surprise due to their sheer beauty and uniqueness. If you would like to request a specific topic, please leave a comment below. As a final note, I would like to thank my new YouTube channel member Stuart